Good. Okay. So, yeah, it tells you this is what the famous facial iris data sets and so forth. If you come here, it tells you that it's what 50 flowers for each 3 species. So the species have been given and so forth. If you come down here, it tells you the format. It is what? A data frame. So the structure we were looking for is what? The data frame, as I have highlighted. It have 150 rows and what? 5 variables. So the variables are the sepal and so and the species. Now, if you look at the head of this, right, you see it as that, right, over here in there. You are done. Oh, which one? And then it means they did not take back. So, yes, these are those who were there. So anyway, I'm teaching them, so let me finish. Okay. Yeah, so the head, we are sepal length and so forth. And yeah, so here, you know, the type, once you do the head, you can see that this is what? Numeric, right? You can say it's numeric. Okay, and so forth. Okay. Now, what else do we need to? The moment. Okay. So the next one, yes. So from your data, so the distinct data types that we have are the numeric and what? This one, those species. So if I look at the structure of the iris, okay, if I look at the structure, that will even give me more. So this is numeric, 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 and then there's only what? One factor, which is what? The species. So this is what I want you to tell me. That's it. So that's the first part. And then the types. So you say that these 4 are of one type. So I don't expect you to go on and analyze each of them. You take one of these, maybe petal width, and then you show us how you can use descriptive statistics to what? To describe it, and then the species is also another one. So this one, what appropriate descriptive statistics can you use? Yes. Yes, you need to speak up so that it's not like I'm just teaching. This is a discussion. You have your script marked and so forth, so you should be able to tell us if even at all. Alexandria or Alexandrina, what um, appropriate descriptive statistics can you use for the petal width? Please, you must unmute yourself and talk.
Please, the question. My network, so I can get the question.
No, I'm saying that these ones, the 4 are of the same data type. So we are going to take only one because that's what the question says. That take one of them and then select an appropriate descriptive statistics. So I'm saying let's take the petal width. What appropriate statistics can we use to describe this data?
Okay, since it's numeric, we could look at the distribution. So we could do a box plot or a
Good.
histogram.
Yeah. So that's it. Maybe a histogram or a box plot for that one. And I wasn't certain. I said you. So I mean, as I said, you'll be going out now. So we expect that you should be in a position to decide. Nobody is going to people will even come to you because they know you have done statistics to do this and so forth. So it is up to you to now be able to, so if you choose, let's say, a histogram, you're going to plot your histogram like this. So petal width, you select your petal width. Remember that I said, and most of you were just leaving it. So it's like when you come to class, you don't listen to whatever we say. I told you that there's no need to put what is it? A title on your plot. And these are the histograms I was saying. Histogram of iris, dollars, and pet. Who understand this when you go out of here? Nobody. Okay. Iris, dollar. They will ask you what is the dollars, and they won't know what you are talking about. So whatever you are doing here, you must treat it as you are doing some work. Okay, so you take it off. It's not there. I have even been using this. Palmer. So it's like all those things that we were doing it's like you are not taking it that serious or whatever. So you just plot anything that you want. So this has been done well, but of course my S as this is not good. So I need to what? Change it to, and if you even come to the help files that you did, petal width, they have not, let's see, if I go up, it doesn't give me the the unit within which it was measured. So I can just name it. But even that, you shouldn't be writing petal dot width. It's just petal then width like this. So that the figure must speak for itself. That this is frequency and then the width. Okay. So from here, I'm going to go straight to 7. In 7, let me open the that for 6. In 7, I asked that you construct a histogram. And the histogram, you should use, yes, Francis, yes. In front of which gate? But where are you coming from? No, you are at the police station. So when you are coming, there's a zebra crossing over there where the runabout is. I'm teaching, I can't come there now. It's not, I'm teaching, I can't come there now. Listen to me. Go to the runabout. You see that people are crossing. There's a pedestrian crossing over there. Yeah, then you cross and come. Make sure that they will stop for you to cross, okay? Okay, all right. So come. Okay, sorry for the interruption. Yeah, so yeah, make sure your graphs are like this. And then I said I'm going to 7. You see, this is a frequency histogram, isn't it? Now, if you go to 7, I said construct a histogram for the sepal width. This is even the petal, but what I asked you was the sepal width. And, okay, it's not even this one. It's okay. Because one, the other one I said, wait, it suggested that the normal distribution, 2 estimation, right functions. Okay. So, otherwise, superimpose the density of the normal distribution gives a better fit. Okay. So, okay, wait. I was actually referring to 7 and then 8. Okay, so you constructed a histogram. Then I asked you to now fit, nobody was able to do it, to fit a density. If you remember in your statistical, methods, right? If you fit a distribution, you can fit the normal, I don't know if I write on this and you people can see. Let me do my what do we call it? Whiteboard, yeah. Okay. So just a moment. Okay, so let me come back to the whiteboard. Stop sharing. Share the whiteboard. This one. Okay. I said you should do a histogram and superimpose your density, right? So you've done a histogram that maybe looks like this. Okay. And then we say superimpose the density. That means you are going to get something like this, right? Okay. Now here, remember density is like a probability between 0 and 1. So it cannot be your frequency, but what? A relative. So you need to get the relative frequency um, histogram before you'll be able to superimpose a density on it. Other than that, when you do your density, the density function will be somewhere here because it cannot go beyond your frequency, which is let's say 100, and here is 50, and so forth. Your probability is between 0 and 1, so you see that it's somewhere at the bottom of it. So these are things that you know you don't expect that with all this we have to, let's say, do this in class for you to know that when you have to plot a density, because you know all this, but it is about thinking on the spot, and this is what you will be encountering as you move on interviews and so forth. Okay, there's a problem that you need to be attend to at the workplace, and your boss is on your neck, trying for you. So you need to think on your feet. So it's not everything that you will find it quite easy, but any problem that you want to solve, you must give yourself some time, think about it, and then you devise your strategy in doing so. So that's the beauty of this course, that it actually help, you need to think through questions and devise. Otherwise, computer, it cannot do anything on its own unless you yourself um, 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 direct what needs to be done. So forth. Okay. Yeah, so that's the concept you have to use to answer the the density part of it. Okay, so I'll move on. So let me now start sharing. Any question on this? If you have any question, you can always draw my attention before I move out of this, because I'm moving from the other one to the R studio so that we continue. Any question? Okay, I assume that.
Please not with my network, so I couldn't answer your question.
Okay, we've moved on. So we
Thank you,
wanted you
sir.
to tell us what descriptive statistics can be used to describe the pattern with. But somebody answered. So we use a histogram, and that's what we've been discussing now.
Yeah.
Okay,
All right, sir. Thank you.
you're welcome. Okay. So now for the histogram, remember that's what I'm saying, frequency. So if you want to do this such that later on you can fit a distribution to it, then you need to now look at frequency. Then you give it false. Okay, so this one is it now becomes a density. It's the same plot. Nothing has changed. It's just that the frequency has been changed to what? A relative frequency. So this one will be in a position to fit a density function to it. That's it. So that's my comment. If you want box plot, you also use box plot to do this. Okay, and so forth. Somebody can also use summary statistics. Okay, then when you say give a summary, then summarize, then somebody is also using summary. So this one, if you want to use summary, you can also use summary statistics because it is what? It's um, a continuous variable. So you can also use that to do what? To describe the data. That's also, or box plots, whichever way. So you are free to choose whatever you want to do. And we said that you can comment on your result. Most of you will not comment. So you will lose the marks. It's as simple as that. Okay. So if you have done this and you got this, you can describe it. So this one, it seems to be what? A bimodal distribution, right? There are two distinct groups for the petals. So I can say that, okay, you have one which is from, let's say, around 0.7 onwards, and then some data from, let's say, 0.6 downwards. So they are like two groups. You have two groups within this petal. If you want to use this one too, you can. The minimum is this, the maximum is that. The median is larger than the mean. So what can we say about the distribution of petal width? Are you there? Any of you can answer, so we move on. Okay. If you are not answering, we move on. But you must comment on it because I allocate mark to the comments as well. And this is start 111. That's why I keep saying when I teach this level. Most of the statistics that you will need are your 111 and the 112 for the basic. Sorry, 1, 2, 2, 3. Okay. Of course, your non-parametric statistics, the 222, and you will need all those things. But 223, 222, and also 111 is very important, and you shouldn't forget about it at all. Yes. Okay. So please make sure you. Yes, please. Yes. Yes. I'm teaching, so you have to be snappy so that I can move on. Start what? Okay. Last semester. Okay. You can come and write your writing now. Moment. Write your writing. I'm teaching, so why not? So, okay. So yeah, so you need to comment on it. Okay. Then so that's one of it, and the next one is the other data, which is so this is for the numeric, the data type. So this is type numeric, right? So we've chosen something, a descriptive statistics for it. Then we also have a factor. Okay. So that factor is the species. So what descriptive statistics can we use for this? The species is a factor, so in other words, qualitative data. Okay, so it comes as 101. Use okay, all right. So anytime, but tomorrow I will not be around. So let's Monday. So yeah, so for species, because it's qualitative variable, we can use maybe a pie chart or a bar chart. So whichever one you are interested in. So with that, you may get a table for it. So table, you table the variables, so which is iris. Okay, but the key thing is knowing that you have this variable. So this is what you need. So this will give you what? And they are all 50, 50, 50, right? Okay. So this one, whatever you do, if it is pi, you're going to get what? The same, what is it? The same sector for it. Okay. And this one, what is your comment? There are equal number of what? Species in this data set. It's as simple as that, and then we'll give you the mark. Okay, so but if you don't, then I mean you lose the marks and so forth. So and please you stop me anytime you don't understand anything. So that's it for the two, right? That's it for the two. Then three. If you have any question, please you can ask before we move on. Then number three, we asked that randomly select 100 observations from this data. And I was surprised that people were having problems with this. And I wanted us to meet in class so that I can look at your face and ask you the questions that I want to ask. Okay. Because we did this over and over and over and over again. Okay, so this is a data frame. So if I say select 100 observations from it, what you need to do is to select 100 random variables from the what? The number of rows, right? So let's say I use an index, then my index will be that our sample observations, okay, from 1 to n row of what? The iris data. The iris, okay. So that will give me 1 up to 150. So I select 100 observations from it. So my x is equal to that, and then my size is equal to 100. Then you ask yourself, do you want to replicate like observations? In other words, can observation be selected what is it, more than once? Maybe this one not the case, but whatever you did, I will still mark you because I wasn't specific. Okay, so this is it. These are the numbers, but that's not my sample. Some were working with this. How can you be working with numbers of no? We said the sample, you are selecting sample from the data. So you must now go back to iris. We took time to do this, right? And then you pass your index through as row, right? And that one. So this will select 100 observations. The first one will be the value of our first selected observation. Okay. So if you look at it, So if we look at our select or 37th, 134. Okay. So it means my first selection is what? The 37th observation. Okay. If I redo this so that all of them will appear on one. There it is. So if you look at it, the first 37, 134. 29, and so forth. That's the same thing you find in the index. So it will select those observations. So this is what you mean by a random sample from a data frame. You use the rows, you select observation for the rows, and then you can now use that to get your sample. We did this over and over and over again, and people are still having problems doing this. Some were able to do it, I must admit, and it is good to see that people are really making an effort in that regard. Okay, and then there we said provide your R code and show the first few observations. Okay, so if I name this my sample, okay, or maybe my iris, my iris, then I run it, I get it. And then we say show the first few observations. So usually that we use head, right? And then you do like this. So if you run it, this will give you that. Okay. And that's it. So that answers the question 4. Question 3. And then when you are reporting on this, you copy your code, you copy the results, and you paste it in your Word and move on. Any question? Any question on this? Other than that, I move on to 4. Question 4. We say you should write your own function to compute a Pearson's product movement correlation coefficient. This, we did it in class, isn't it? Have we not done this in class?
Yes, sir. Yes, sir.
Yes. So it's
Yes, doctor.
just a function, you name it, and then the formulas, you just pass it through, you do your formula. So the skeleton, I'm not going to do this because you need, let's say my Pearson, okay, is the name of your function. The function, this is a correlation, so it needs x and y as in it. So x and y, right? X and y. And then you come in here. I remember we did a numerator, isn't it? Numerator, we get maybe the n
Yes, sir.
length. That's all. Okay, so it shouldn't be a problem at all. And I said write your own function, so you cannot go and call and say that is your function. That's not your function. Okay, so just go over it, and that's it. Once you finish, we expect that you use it to what? To compute the correlation between the sepal length and the width, right? Okay, so you do that, and then let's say if I have finished with this and I've written it well, okay, I will do my piercing. Somebody did this. Somebody did this, and they say return. Let's say call XY. Okay. This I want to know that you can what? Find correlation. That's why I was specific that write your own function. So this cannot be your own function. Okay. I want you to write it from scratch, and that's why I gave you that. So don't follow me like I'm doing here. You have to write it in the formula, just like we did in class. So what we wanted was a sepal correlation between sepal length and then sepal, sorry, iris, then sepal width. This is what we wanted, and you get something like this. Okay, when you compute this, there's there's comment on your results. So you must tell us that there's this what a weak negative correlation between what sepal length and sepal width, which means as the sepal length increases, what happens to the sepal width? What happens? So it is not enough to say that there's a negative correlation. You must identify it. Say that it is what? A weak negative correlation, which means when sepal length increases, the sepal width what? Decreases, but of course in a moderate manner. So that's it for that part. And let me issue a disclaimer. So I said this, you must key in the formula that you were given, not like that. So that's it for 4. If you have any question, you can ask before we move on to 5. So 5, we said use an appropriate descriptive statistics to help you compare the distribution of sepal length of the various species. How many species do we have? Vincent, how many species?
We have 3
3
species.
species. Yeah, so here we said this appropriate descriptive statistics to help you compare what? The sepal lengths of the various districts. So you have to now choose what you want to do. Okay. Well, you can compute the summary statistics if you like. Okay. For each of them, that's also okay. But remember that we did box plot. That's easier to help you compare things quite easily. So in this case, I will recommend a box plot. It doesn't mean that if you use another thing, I'm not going to mark you. Okay, I will. So I'll use a box plot. But here it is your data, right? So my arrays, and then you want what is it? Sepal length, right? So sepal, okay. So I want to get it right, so I can call names of this, so that it gives me, and then I'll just copy. In that case, I won't make any mistake, right? So box plot sepal length. So this one. So I'll plot sepal length as a function of what? Species in my iris data. So I don't expect all of you to get the same answer. Okay? Yeah, so you do it like this, and there it is. If you like, you color them to make it nice. So maybe 2 to 4, right? 3 of them, something like that. Nicely done. Okay. But even the Y lab is no good. There's a dollar sign there. So if I'm marking, I'm looking at all this. Okay, and as I said, don't treat this as if you are doing this for exam's sake. You are going out, so make sure you learn and not do things as it should be it should be lab rather, in a professional way. So that when you write a report and you get your output to your immediate boss, they will be happy about you. After your service, they want to retain you. But if they say do this, then you are giving them dollar sign and so forth. When it comes to recommendation, nobody will be looking at you. Okay? So please take this serious. I mean, most of the things, those mathematical, prove this, prove this. I mean, if you are continuing your course, you will encounter them. But if not, hardly will you may not even encounter any of them before you even, die from this. So, but these ones, you need them to be able to do your everyday stuff. So please make sure you understand some of these concepts as well. As I said, somebody may also choose to what? Compute summary statistics for each of them. That's also fine. Okay, and then you comment on them. Did we say comment on this? To help you compare. Yeah, so you can talk about it. So here you can say that there seems to be the Virginica species seems to have longer sepal length than the others, followed by versicolor and then what? setosa. So setosa is the least, the group without the least sepal length, something like that, and you are done. So that's 5. Then 6. So 6 follows from 5. So if you do this, it's easy now to do 6. So 6, is there enough evidence to conclude that the average so and so is at this level? I expect that you check, and I was happy to see that some of you were checking whether the variations are the same, whether maybe they come from a normal distribution and so forth. So that's what you should be doing. Okay, that is what would distinguish between you and somebody who has done less is just psychology and still applying, or maybe biometry at the agric department and it's analyzing these data. They will go straight and be using ANOVA. That's not what you should be doing. You should be checking the data to see whether it follows normality and so forth. Okay, so here, first of all, you can check for normality. So you check the assumptions before you select your test. And normality, what did we say? We said we can use Shapiro test, right? Yeah. So for even a start, we can just check the it's called iris sepal length, right? Sorry, we are using my iris, not the entire data. Most of you did not adhere to this. I just marked you, but please make sure that you don't do same in the exam. So this one, sepal length, yes. Okay. So I can check this and see. So if you look at the p-value, it is less than 0.05. So we will reject normality. We can also, some also did Bartlett test. Remember, if one is not even satisfied, you are good to go, right? So the Bartlett test, you can do it. I think, were we able to use the formula? I think so. Some do not work, but let's try. I don't remember. So everything that I remember often, but yeah, so it does work. So we do it, we pass it through it as a formula. Our P is equal, so there's no equality of variance is rejected. Okay, homogeneity is the same as equality of what? Variances. So we reject that. So it means that this one, you don't need to do ANOVA. Okay, somebody did that. I marked the person, but as I said, in the exam, if you do that, I won't be able to, give you mark just like that. And this is what test for equality of variances. But this is what you do in practice. So you should be able to distinguish yourself between this and somebody who has just done star 224. Sorry, 240, because at that point I can't be teaching you because you have not done so. But now you've done all those things, so don't take the shortcut. And now you can do maybe a Kruskal-Wallis test. Oh. So you use a Kruskal-Wallis test, same same thing. So that's our Kruskal-Wallis test. What's our test results? The results show that what? Our p-value is very small, almost close to 0, 13 zeros before the 3. 0.00013 before 0.13 before this one. So what do? We will reject the null hypothesis of what? Equality. Yes, equality of what? Means for this. In this case, medians actually, because we are not using what? The mean, because of the large observations, like the outliers and non-conformance to what normality. Okay, Now, so the next question was that choose your own. Which species has the longest length? Okay. It seems to be this, but if you want to do this, remember we did this in class, and some of you were able to do it. I was happy to see it. Because you can still install your, let me see, the one who got 53. Yes, the person did it. Good, no, you couldn't. But somebody did it. Um, use the dance test, install the package, and so forth. That's what you should be doing for such a problem. So you can now use that one to now be able to select which one. But definitely, if anything, it should be what? The Virginica. So you can do that. And that answers question 6. Okay. And then 7, if you have any questions before I move on to 7. 7 was that you construct a histogram for separate ways. We've talked about histogram and comment on the distribution. Actually, I wanted you to do that so that you can fit this into it. What do we call it? So SEPA, sorry, my iris, and then you SEPA with rather, okay, and then mean we've done this before, so and then X lab should be what? SEPA with like that. Now, if I read the question onwards, so when you're doing examination, make sure you read all the questions, brainstorm over it before you start. So if you do this, if I'm doing it, I know that if I'm coming to do, then I'll check frequency to this so that I'll be able to get access to it. So like this. So that's the separate way. Density and so forth. So we can come back to this and fit our distribution to it and so forth. So that's it for 7. Comment on it. This I mean slightly skewed to the right, but not so it doesn't deviate so much from normality. And so that can be a comment, and you are gone. Then the next one is that 8. If you have any question other than that, I move on. 8 is that it has been suggested that what a normal distribution can be fitted to the SEPA with, right? Which is what we have done. 2 estimation methods, method of moment and maximum likelihood, have been selected. Write functions to compute the estimates of the mean and variance of the SEPA width of these using these 2 methods. Okay, I wasn't specific, so you can use a package to find it, and that's fine. Okay, or yeah, so that's okay to use package to do it. So we did fit.dist R plus, if you can install it to do it, that's okay. You can also use what the fit.dist R to do it, whichever one is fine. Okay. So if I let it norm dot par, if I'm using normal parameters, I can use fit.dist R. It means I have to get what mass package, right? Other than that, I can't use that. So now, if I start fit this R, I have it, okay? So X will be, what did I even say? I said, write function to compute the estimate of the mean, so and so. Yeah, okay. But ideally, this one, you should be doing, like writing your own function to do this thing. And I think we did it in class, right? We did something like that in class, isn't it? Are you
Yes, we
with
did.
me? Yes, we did. Okay, good. So my iris my iris, and then it's not separ width, right? Okay. And then dense fan is what? In this case, normal. Okay. So I can use it to get my normal. So those are the means and the maximum likelihood. Oh, norm MLE, I should say, not MLE. Okay. And then the moment I may not be able to, you can get, I think you can get it, I don't know whether face this, but that is not a problem because I can just write a small function to do this. Okay, so let's say my mom is what? A function. Remember, you've done this in your 333, right? So this is just the mean of x, and what? The variance of x. Those are the method of movement, right? That's it. Okay, so, and then when I finish, I can now say my norm dot MOM. Yes, is just what? My mom, and then we just pass our data through it. So, okay, thank you. Do I owe you? Do I owe you another paper? Yeah, they will bring it maybe tomorrow or Monday. Thank you so much. Okay. God bless you. So I need to give one to another person. Okay. All right. So now we have, okay. So that's our estimate for the mean. Thank you. For the mean and the variance. Oh, sorry. This one is a standard deviation, eh? So, yeah, but we wait. Let me go back. You see, let me select it. Where computer estimate mean and variance. Yeah. So the maximum likelihood one, if we want the variance, we need to square that one. Okay. So that's it for the 3 and 8. So that's 8. Yeah. So 8 at least. Or even though I would have wished that you write your own, but I consider the time too is not enough. So if you write it, that's fair enough. 9 is that from your results in, as I said, should be 7 to 8 or otherwise. So even if 8 is not working, otherwise, superimpose the density function of what? The normal distribution using your estimate from the moment and the maximum likelihood method. Which method gives a better fit? Remember that our, look at our distance. Okay, so in this case, we are getting something close. Okay, so we look at the mean, the maximum likelihood. It's almost the same as that one, right? Maybe if we go more, then we'll get this one. The standard deviation or the variance may not be so different as well. Okay, but let's see. Okay, so to do this, we have to go to our plot, right? And this is what do we call it? Yeah, so two things. If I want to do this, I can take, let's say, simulate or get sequence from 2 to 4, 4.5. If you look at the range, it's 2 to 4.5. So I can see that, let me say my S lim or S, let's say, what should I, let me say S that is this. So that's one way I can sequence observations from 2, from go to 2. We did this, right? 2. What is it? 4.5. Okay. or let me say 5 by, if we want, maybe 0.01, so to speak. So we have the longer we, or the more we use as that, then I can now get the density of these values. Remember, you want to plot a density graph that will, like I illustrated previously. So you have this, now you have to find your density for the, so this is a normal distribution. So d norm, okay, we talked about distribution, simulating observations from distribution. So now we have the x's, we want the distribution that is associated with. So we need d norm. Okay, so what it means is that if I take each of these x, right, I can get the corresponding y dot by getting the density. So the density will be equal to the, sorry, the x are our quantiles, which is this, then the mean. So let me say that MLE. So then it means I have to use the MLE1, norm MLE. I call the mean, then I call what? The standard deviation. So it's just like all these things, you know, but it's up to you now to put this like in practice, what you should be doing. And then SD will be the second observation. If I do this, you see that the mean will come 3.0. That was the mean. So if I change this to 2, I get what? The variance. So for log, I can take that one out. It's not needed. So now I can get these are densities. The y dot MLE are densities. Have you seen like that? Okay, they are densities. Another way to go about this is that we can also, which will even be the proper way to do it, is that I can, you know, the normal distribution, you need the mean, and then we can spread this. We can spread it as well by simulating it maybe between plus or minus 3, right? And then we do it like that. So let's see lines, x dot, and then y dot. Let's see how this will work. There it is. So this is what I wanted you to do. Is everybody okay with this? That's it. It even goes beyond. So if I want this to come, I have to increase my this. So that's the first one, which is the MLE. So I can also now go back and do one for what? The that of what? The what do we call it? So this one I'll use on mom, right? So that I use the moment estimator. No mom. As for this, nobody was able to do it. It means you are not exploring more, not oh, thinking outside the box. You always want us to, it has to be something that you have done in class. But as I keep saying, life doesn't work that way. Because you know the concept, you know what a probability distribution is. Okay. So now, invalid. Oh, okay, yeah. The moment I don't need an estimate, it's just two values like that, like that. Okay. Then what else? I need the lines, and now I can even color it so that I'll get to know how. So this is mom. And then I color it so that we will know which one. Have you seen? Okay. So now you see, I can even do what? Legend and show you that. Let me go back here and do this histogram. And then let me put y lim. You know this, that we can, the limit, the y, we can limit it to between 0 and 1. Have you seen? So now you see that that's how you can limit the x to using what? S-lim and so forth. So now I can see my graphs quite well. So I can line this one. Okay, you see? And then now that one. Okay. So now you can make a decision. Which one fits the data properly? From this graph, which one will you choose? So that's it. I think you know that's what I required from you. Any question? Any question on this? Other than that,
No, please.
that's it. So there's more to do. As I kept saying, if you were waiting that 1 week to the exam, then you please it will be like what you have done. But as I said, some of you did very well, and I'm happy for, for you. So some of you, when you come to pick your form, you see that I've said you should see. There's the performance unit of the university, the HROD. They need somebody who is good with analytics, but of course that will be programming. So if you know how to do some of this in plot and so forth in R and other, and with your statistics background, they will need you. And there's a likelihood that when you finish, the university might take you on. So if you are interested, you can let me know and then I'll send your details to them. So thank you for coming. I'll put this on YouTube and send you the link so that those who were unable to come, they can also have access to it. So,
Sir, please, can we come for our script?
yes, I'll put it in front of my office so you can come. All right. Thank you.
Thank you, sir.
Enjoy your evening. Take care. Bye-bye.